Okay, so we lost our first video somewhere off in La La Land, I guess. So we're going to try this a little bit again. Make sure, hopefully we don't lose this one. Okay, so we set up, I already have all the pH water set up with a teaspoon of the pH indicator and a half a cup of water added. The first one we're going to add baking soda. And the baking soda just changed the color, the shade of blue a little bit, which means that it is a base. And second one, we're going to add some pineapple juice. And that changed it to pink, which makes it an acid. And then we're going to add some drain cleaner. Now this one is actually a little shocking to me because when I was looking up bases and acids, it listed drain cleaner as a base, and I would have thought it would have been an acid to eat through all the stuff that's in the drain. But it turned like early green, so it's definitely a base. Okay. Then we're gonna try some milk of magnesia. Which is the green, so it's another base. And my son wanted to try rubbing alcohol, just to see what it'll do. It actually does nothing, so it would be like water, which would make it neutral. Now this one, my son did not want me to use, but I decided I was going to anyway, because it is also listed as an acid. And I am over 21, so I am perfectly legal to be using this. We're going to put some beer in this last one. And it turned it pink. It really is an acid. That might be why I don't like beer. So then we've got 2 acids, 3 bases, and 1 neutral. Now I've enlisted the help of my son to help on the next one. And we're going to let this one's the pH water. We're just going to leave alone. And then he's going to blow bubbles into this glass while I answer the questions that we're supposed to answer. Hold on to the glass down here. The other hand. Okay. The first question was we were supposed to explain the process of ocean acidification. Basically, a third of the fossil fuels that we burn off go up into the air, and the CO2 from them is grabbed up by the oceans. The oceans actually absorb them, which will react with the water, and it becomes carbonic acid. The carbonic acid lowers the pH level, and it makes the ocean more acidic. The second question was, I don't remember specifically what it asked, but it asked something about whether we should be concerned about this, and yeah, we should, because after a while, It's going to do some permanent damage. It's going to damage the ecosystems of the marine life. Um, some of the organisms living in the water might experience lower metabolic rates and or lowering of their immune systems. The acids can cause problems with the shell growth in some of the marine life as well as the reproductive issues. The acid basically it'll dissolve the calcium carbonate in coral reefs, which has an effect on the whole ecosystem, all the ecosystems in the water. And eventually, the effects that these ecosystems have went through are going to indirectly affect the other ecosystems of the world, because the food web basically it's just a circle. So eventually, it's going to have an effect everywhere. Okay, that's good. That's good. Okay, so we have our blue indicator water there, and then we have the glass that he blew bubbles into. And it's kind of hard to see. I don't know if this is going to have much difference, but the one he blew bubbles into turned pink, and the other one is blue. Oh, no, it's purple. Okay, it's a purpley pink.